If you're in a cell, cytoplasm heading outside, your last stop's a barrier 8 nanometers wide. The cell membrane, our subject for today, it's as basic to life as DNA. It's selectively permeable like a border patrol of a country. It maintains control, selecting what leaves or what gains entry. It's a guard, bouncer, watchman, patrolman, or sentry, but not just a guard. It sends signals and nerves. White blood cells use their membranes to eat germs like hors d'oeuvres. Membranes have receptors, enzymes, and junctions. So what kind of structure can have all these functions? C-double-L-membrane, control and transport, selective permeability. Phospholipids, carbohydrates, proteins, and cholesterol. The fluid mosaic by layering us all. So let's take a look at what makes up the membrane. Phospholipids rule in this domain. In fact, membrane structure emerges directly from phospholipids' chemical properties. There's a head and a tail on every phospholipid. The tail's 2 long-chain fatty acids bound to a glycerol. It's made to order. The tail's non-polar, hydrophobic, fears water. The head's got a phosphate. It's charged negatively, makes the head hydrophilic, plays in water happily. So tail avoids water while the head's attracted to it. When phospholipids form the membrane, that's how they do it. Cause when phospholipids into water get submerged, a phospholipid bilayer structure will emerge. The tails hang together in a water-free zone. Hear the hydrophobic moan, water leave me alone. While the heads are sticking out, touching all those H2Os. Tails in, heads out, it's how every membrane goes. Tails in, heads out in a cellular sphere. It's the bilayered basis of membranes everywhere. C-double-L-membrane, control and transport, selective permeability. Phospholipids, carbohydrates, proteins, and cholesterol. The fluid mosaic by layering us all. But a cell membrane's not just a phospholipid scene. There's cholesterol, carbohydrates, lots of proteins. In fact, membrane proteins have a presence so great they often exceed the phospholipids by weight. And all of these components are in constant motion, moving, mixing like a boiling potion, flowing like dancers in a party in Passaic. That's why the membrane's thought of as a fluid mosaic. Let's start with the proteins since they're key in this mix. Transmembrane proteins span the entire width. Typically they're ports, think of channels of conveyors for things that don't go through the lipid bilayer. Any protein embedded in the hydrophobic middle built right into the inside is considered integral, while peripheral proteins either hang on the exterior or on the cytoplasmic interior. Cholesterol keeps membranes flowing with ease. In cold it keeps the lipids moving so they don't freeze. In heat it slows the lipids down, limiting their traveling. Cholesterol keeps membranes from unraveling. Membrane carbohydrates work as markers or signs, so your immune system knows which flag your cells are flying. The blood types A, B, O, and B and A are about the carbohydrates on red blood cell membranes. C-double-L-membrane, control and transport, selective permeability. Phospholipids, carbohydrates, proteins, and cholesterol. The fluid mosaic by layering us all. C-double-L-membrane, control and transport, selective permeability. Phospholipids, carbohydrates, proteins, and cholesterol. The fluid mosaic by layering us all.